Welcome back to our geometry series. Today we're up to section 8.1 where we'll be looking at prisms. In the past we've looked at figures like triangles, quadrilaterals, and circles. Today we're taking things into the third dimension. And now we have a polyhedron. A polyhedron is a geometric figure made up of a finite number of polygons called faces. The common polygon sides are called edges, and the common points are called vertices. Here, the face is highlighted green. Here, one of the edges is highlighted red. And here we have one of the vertices, or one vertex, highlighted in yellow. Next, let's take a look at this piece of cheese-looking thing. Let's identify the top and bottom as triangles ABC and triangle DEF. Next, let's state that the two triangles are congruent to each other. Next, we'll define these two triangles to be parallel to each other. And finally, we're going to say that the faces ACFD, ABED, and CBEF are all parallelograms. If we can state all three of these conditions, now we have a prism. A polyhedron is a prism if and only if it has two congruent faces that are contained in parallel planes and its other faces are parallelograms. The two congruent faces are the bases of the prism. The other faces are called the lateral faces of the prism. So here, the parallelogram ACFD, ABED, and BEFC are the lateral faces. Lateral faces intersect at the lateral edges, all of which are parallel and congruent. So AD, CF, and BE. These three segments are the lateral edges of the prism. Let's go back to this prism. And now we're going to define that the lateral edges are perpendicular to the bases. If the lateral edges are perpendicular to the bases, this creates a right prism. If the lateral edges are not perpendicular to the bases, this creates an oblique prism. So in this case, we've taken the upper base and just kind of slid it over. The prism would no longer be right. We would call this an oblique prism. Next, let's draw a line segment that is perpendicular to both bases, as shown here. A segment is an altitude of a prism if and only if it is perpendicular to the planes of both bases. The length of the altitude is called the height of the prism. In a right prism, the height is the same length as any lateral edge. Next, let's go back to this original prism. Let's talk about the area of this one face. Specifically, we want to talk about the lateral area. The lateral area of a prism is the sum of the areas of the lateral faces. So in this prism shown, there would be 4 lateral faces that we would need to add up. The total area of a prism is the sum of the lateral faces plus the area of the two bases. So that would be a sum of all 6 sides of this prism here. And that leads us to theorem 90. The lateral area L of a right prism equals the perimeter of a base, P, times the height, H. So L equals P times H. So let's start with a right prism and add some dimensions to the base. Next, we'll add an altitude, or in this case the height, 7. We know that the altitude and the height are the same because we've defined this as a right prism. Let's start with the perimeter. We know the perimeter is 5 plus 6 plus 6 plus 5, which is equal to 22. We know the height is 7 as shown. So the lateral area will be equal to the perimeter times the height, or 22 times 7, which is 154. Next, let's talk about the volume, kind of a 3D area, or how much water would fit inside the prism. And that leads us to theorem 91. The volume V of a prism equals the area of a base, B, times the height of the prism. So V equals B times H. Let's start with that formula. Let's add those same dimensions again. But this time you notice it just says prism. It's not a right prism. However, on the top base, we can see that we have a right angle. Imagine looking down on the prism like this. You can see the four sides of the base and a right angle. So the volume equals the base area times the height. The base area will be 5 times 6, and the height is 7. So the total volume would be 210. If we had units like meters, our answer would also have to be in meters. In this case, we're working with a three-dimensional object, so it would be 210 cubic meters. Let's jump over the whiteboard and do some examples. I mean, it's a triangle, but it's a prism. It's clearly a prism, but it's a triangle, so is it supposed to be a triangle, or is it a prism? Because see how it's a prism, but it's a triangle. I mean, what were they thinking when they tried to put... Okay, I'm going to draw a polyhedron, so a three-dimensional shape. We're going to start like this. We're going to draw some edges down that are sort of straight, like this, like this, like this. And then we need to draw the edges that you can't see, so kind of behind this back corner, back here, and back here. So we've kind of got a hexagon top and a hexagon bottom. But I want to define this as a prism. So what that means is that this hexagon is congruent to this hexagon. It also means that this hexagon and this hexagon are parallel to each other, and they become the bases of the prism. And because we've defined this as a prism, it means that all of the edges are parallelograms. So we've defined this as a prism. So let's count some different things. So vertices. So how many vertices do we have in this prism? Well, if we look at the top base, we have 1, 2, 3, 4, 5, 6. Remember, our vertex are where the lateral edges meet and touch the other sides of the base. So we have 1, 2, 3, 4, 6 on the top and 1, 2, 3, 4, 5, 6 on the bottom. We have 12 vertices. Next, let's look at lateral edges. I can spell lateral edges. Again, we're not counting the bases, we're counting the lateral edges, kind of the sides of the prism. So this is 1 right here, kind of the front. That's 1. This is 2. This is 3. The back would be 4. This would be the 5th one. And this here is the 6th one. So we have 6 lateral edges. And finally, we'll do an easy one here. How many bases do we have? Well, because of the prism, we have to have exactly 2. Again, that's kind of the top of the prism and the bottom of the prism. Next, we're going to draw something like this. And we're going to have a kind of back edge, and an edge, and an edge. So it's kind of a cheesy prism looking thing here. And then what we're going to do is define this as a right angle. And again, we have a prism. But now it's kind of on its side. So this is the base, and this is a base. So this is a lateral edge, this is a lateral edge, and this is a lateral edge. So we want to find the lateral area, L. We also want to find the total area, so T or TA. Again, total area would be the sum of all of the sides, not the volume, but we're going to find that too. So remember, lateral area, again, it's the area of just the lateral edges, is equal to the perimeter times the height. Now, we probably need some numbers on here before we go any further. So let's just say this over here is 8. This little back wall here is 6. And this length is 12. Okay, so how do we find the perimeter of this prism? We've only got 2 pieces of the base perimeter here. And we could actually draw them up here because we know that this is going to be 6 and this one's going to be 8. Because we have a prism, this base is congruent to this base. So this is kind of our mystery here, right? We need to know what this is to add up all the sides here to get the perimeter. But we happen to have a right triangle. So we know that 6 squared plus 8 squared is going to equal x squared. So let's just write that out. 6 squared plus 8 squared equals x squared. 36 plus 64 equals x squared. So 100 equals x squared. Now we just take the square root of both sides. Yoink, yoink. And this becomes 10 equals x. And because we're dealing with actual distances, negative 10 is not a valid answer. So, square roots and all that fun stuff. So we can make this 10. 10. So now we can find the perimeter. All we need to do is add up these three numbers. 10 plus 6 plus 8. And that equals 24. And we need to multiply it by the height of the prism, which is 12. So this equals, squeezing in here, 288. I think we're going to need some more room for the next problem here. So let's get rid of this. And we know we need to find it, so we'll just put a reminder down here. Find the volume. Okay, so total area. Total area is the lateral area plus the area of the two bases. Okay, so we need to find basically the area of every side of the prism. So let's start with the lateral area. It's going to be this area plus this area, kind of the back, and then the bottom. So let's just start with that one. This area of this prism, remember, this is perpendicular because it's a prism. It's just going to be 8 times 12. 8 times 12. And then we're going to add, let's say, this back wall. It's going to be 6 times 12. Remember, 8 is this length, not this length. So this is the height, 12. 6 times 12. We're going to add 6 times 12. And then we need to find the area of this bottom lateral edge, or lateral face, sorry. So it'd be 12 times 10. 10 times 12. That's a 10 plus. So this is 96. This is 72. This is 120. So we can add all these up. It'll be 288. But that's just the lateral area. So this number here, we still need to add the area of the two bases. So what's the area of one base? Well, that's a triangle. Whoops, this is 288. Let's keep that on the screen, shall we? Let's look at the prism top down. See if I can keep this on the screen here. We have a right triangle, right? The hypotenuse is 10, and this is 6, and this is 8. So this is the top of the prism. It is a base. We need to find the area of this. This is pretty easy. The area of this triangle will be 1/2 the base times the height. So 1/2 of 6 is 3. 2 times 8 is 24. So the area of this triangle is 24. And the area of this triangle is 24. So when we're taking this total area, it's the lateral area, 288, plus the two bases. I already forgot. So it's 24 and 48 plus 48. That equals 336. Whew, finally. So the total area, adding up all of the area of all of the lateral sides and the bases, is 336. Whoops, we forgot to find the volume. Remember, the volume of a prism equals the area of the base, B, times the height of the prism, or V equals B times H. So we take the area of the base, which we know is 24, times the height, which is 12. So 12 times 24 is 288, and that would be the volume. Let's clean this off and do a bonus problem. Okay, this is going to be a weird shape. Let's see how well I can draw it. Let's add some lengths here. That's 12. This is 4. This is 6. No, we need a back wall here. This is 1. And this is also 1. And everything is, perpendicular to itself. So we have kind of like this U-shaped kind of beam that goes this way. And what we want to do is find the total area. So we need to add up all of the faces of sums of all the faces. So we've got a big rectangle here. We've got one on the bottom that you can't really see, right? You can imagine the bottom is somewhere around here, right? We've got this weird thin one that runs through the bottom of the channel. We've got this wall on this side. We've got the back wall here. We've got this larger back wall. We've got little walls back here like this. So there's a lot going on here. Something like that, right? And you can imagine that this connects to here, right? It gets complicated when you start drawing all the dashed lines. So to make things a little easier, we know that this total length is 4, and we've got one up here and one up here. So this small distance here is 2. So to tackle this problem, I'm going to think about it in the ways I can look at this shape. I'm going to start by looking down at it. So if I were looking down at it, let's try to draw that. It would look kind of like this. Right? You'd be looking down into the channel, right? So this wall here, or this face, is this, and this one is this, and this is down inside the channel. So I'm looking down at it. This is 1, this is 1, this is 2, again 1 and 2 and 1. This length is still 12. So we have 12. We can almost count this face, right? This is one of them, which is what I just squiggled in here. This one is this one, and then this one down here is this whole section. So we could add them, we could do them individually, or we could do it all at once. So it's really 4 times 12. So the area of these 3 squiggles is 48. Let's put that down here. So total area, I can be on the screen if I really try, equals, we know it's 48 plus some other stuff. We haven't gotten there yet. Now let's imagine we're looking at the bottom of this shape. We would just see a rectangle. It would be a 4 by 12 rectangle. This face here, which is also 48. And we know we have more, so let's put a plus. So we've got the top view and the bottom view. Now let's look at the side. If I'm looking at this large side, it would be a 6 by 12 parallelogram. And that would be 72. But the backside that we can't see, is also 72. So we've got this view, we've got the bottom view, we've got the side and the other side. So now we're getting to the weird part. We have this U face on the front and the U face on the back. And let's try to draw that kind of next to everybody here. So it's going to look like this. So what's the area of this thing? Let's put in some numbers here. This is 4, and we're going to get rid of this 12 to avoid confusion. We'll just put it over here. Remember, the height of this is 6. This is 1, this is 1, and this is 2. So how do I find the area of this weird shape? And this is also 6. Well, let's just chop it into sections. Let's do it like this. Let's chop it into 3 sections. We've got a 1 by 6 section, a 1 by 6 section, 1 by 6 section, and then what's this here? Well, I guess we never specified that the total width of this shape is 1. So from here to here is also 1. So this is 1 by 6, that's 1 by 6. So the area of this area would be 6. So this is a 2 by 1. So this is 2. So let's look at it here. Area number 1, area number 2, and area number 3. So 1 is equal to 1 by 6. 1 times 6 is 6. Area 2 is also 1 by 6. And since this thickness of the whole channel thing is 1, it's 1 by 2. So area 3 is 2. So the total area of this one face is 6 plus 6 plus 2, which is equal to, almost on the screen, we'll just call it 14 for this U. But we also have a back U. So we have to add Well, let's just erase some stuff. This is the front U, and this is the back U. So let's just make sure we have everything here. 48 was looking down on it. 48 was looking up from the bottom. 72 was this side. 72 was the back side. 14 was this, and 14 was this other backside U. But we're not quite done. We have these inside walls. So this wall all in here that hasn't been accounted for yet. So what is this distance? Let's get rid of that marking. Redraw this line. So if this height is 1, right, from here to here must be 5, right? So this back wall is 5 tall and 12 long. So that's another 60 there and another 60 on this inside wall that we can't see kind of around the corner. So 5 times 12 is 60. This is 60, so we need to add 60 and 60. So we add up all these numbers. The total area of all of the different faces of this object equals 388. Whew, finally got there. That's it for today. We'll see you next time.